This conference will now be recorded.
Okay, cool. Guys, can you see my screen now? Just give me a second. Can you guys see my screen? Okay, that's cool as well. So, do you want me to start? Because we are just 80 people, and I guess there were like 114 people that we are expecting. All right, we can start as well. Okay, so I'll just move this to the other part. Okay, someone's name is Dell. All right. So, in this session, we are going to talk about cloud computing development models. Actually, there's nothing like a development model. So, what I'm going to talk about in this whole session is about what do you have to look at while thinking about developing on the cloud environment. So there are a lot of things that you have to take into consideration when you want to develop something for a cloud-based environment. So we look at that here as well, and we will look at how are the career opportunities over there and what do you have to learn in order to actually um, make it work. So firstly, who am I? My name is Faiz Mohammed Khan. I'm a freelance consultant and trainer. My primary focus is on cloud native. So I'll talk about what cloud native is if you guys do not know. So currently there's something going on and people are looking to actually explore this domain, which is cloud native, in which they are trying to find out ways in which if you write an application or any API with this focus or this approach, this application will be able to stay on the cloud really well. So when you have to move from one cloud to another or move from one of like cloud offering like IaaS, platform as a service or any other thing, so that will make it very, very easy for a developer or operations guy to move this kind of application from one platform to another. So this is what cloud native is. It's currently still under construction. That's what I would like to say as well, because this is a relatively new thing, and everyone, or you can say like big players in the industry, they are still trying to find out ways in which you can actually make this thing better. So I'm exploring with the environment as well. So I will talk about what people think of cloud native at this point of time, which might change afterwards because this is an area which all the people are still exploring and trying to find out new and better ways as well. So I'll just talk about the state of the art things that have already happened, and with time I will show you like I'll show you things where you can get updated about these things and like actually grow with all the people in the industry as well. So currently, because of the coronavirus situations, I'm trying my hand as a YouTuber as well. It's not really going really well, but I'm still trying. Another thing I would like to say is that I have a master's degree in cybersecurity. So the thing is, other than the career opportunities, if you want to ask me about what are the like further learning or other opportunities like further studies, you can ask me after the session as well. That's fine. My Twitter handle is at the rate ghost0x07. And one thing that I would like to say is that I'm really, really bad with slides. So you will see here, like throughout these slides, that I have just put some images on. Normally, what I like is like a blackboard kind of thing. So I will switch to my Visual Studio Code text editor to type out few things, or I'll go to Paint to actually draw some diagrams as well. So you might not find everything in the slides, but I will just cover them all using Paint or like Visual Studio Code. So now I want to know something about you because I lack few information about you. So the first thing I would anyone can talk about that. First thing I want to know if all of you are from the same course or the same subject or anything what is the common thing between all of you? Can someone just type it in the chat box or like even open up their mic or say about it? So what I want to know is if I know some details about all of you, I'll try to modify all the slides and I'll try to talk about things which are more inclined towards you rather than talking in general. Okay, you guys are all from the same course, BTech CSE. Okay, so which year are you guys in? All of you are in second year? Okay, it's a mixture of second and third year. Is it a mixture of second or third year, or is it just second years? Second years only. So someone said third year. Okay. Okay. So one thing I would like to know before I proceed further, can you give me examples of some subjects or modules that you have already covered related to cloud computing? Like, you don't have to give me an exhaustive list. You don't have to talk about everything that you have done. Just give me a few pointers so that I know more about you guys and like what you have done. So any examples of subjects or modules that you have done related to cloud computing? Or are you guys relatively new to this thing? Okay, AWS cloud deployment models, performance tuning. Okay. Is your course like CSC with specialization in cloud, or is it just plain CSC with some models in cloud? Okay, what's the full form of that? CS plus CCVT. Okay, it's specialization. All right. So what's the full form of CCVT? Cloud computing and virtualization technology. I think that's what it is, right? Okay, yeah, exactly. Thanks for the response. So, all right. So first thing, let's begin. Okay, let's begin with this thing. So this is something that I normally like to talk about with people. So when I say about cloud native things, there are like four or five things that you need to take care to actually do something really well in the cloud computing environment. So this is okay. Someone's mic is open. Can you just turn off that mic, please? Okay, mute all. All right. Can you guys still hear me? Okay, that's good. So this is something from my own experience. The thing is, when you talk about cloud native, okay, again, going back to the base one. So cloud native is an approach that is currently picking up a lot of pace because of some foundations or some organizations that have come up with it. So when you talk about this cloud native approach, the cloud native approach tries to solve a lot of problems that you have on the cloud computing platform. The primary problem that it solves is that when you write an application for a cloud environment using the cloud native approach, you can switch between so it allows you to have a very smooth transition if you want to switch between, for example, like a cloud computing platform like AWS to Azure or Azure to GCP, or if you want to go from a infrastructure as a service like EC2 to function as a service like Lambda. So it makes things easier. So this is something that a lot of people are looking at. So when you talk about cloud native, they have not primarily described how things are. This is something that I'm talking about from my own experience. So if you want to do the cloud native approach, you need to know about five things. The center of this thing is cloud computing. And then you have to talk about containerization. Then you have to talk about DevOps or DevSecOps. DevSecOps is a new thing. And you have to talk about CI/CD and you have to talk about microservices. So out of these things, which are the things that you have not heard about so far? Or have you heard about all the things that are here? Okay, DevSecOps is something new, but have you heard about DevOps? Yes. So have you heard about all the things, like all five of these things? Okay, you have not heard about CI/CD. Have you heard about continuous integration and continuous delivery? Well, it actually took its inspiration from assembly lines. So people looked at assembly lines and they came up with a software-based thing of that. So CI/CD is kind of like assembly lines for software programs where everything happens automatically. So as soon as you save your code, your application is delivered as well. You don't have to do all the things in between. But have you heard about CI/CD in your course, or do you know it from yourself? Right. Okay. Assembly lines. Oh, yourselves. So what do you mean by assembly lines? Assembly lines is a factory-based concept. So it happens in factories. So when you talk about computer science or like cloud computing, you just have pipelines, which are CI/CD pipelines. You do not have anything like assembly. Some other thing which is in computer science related to assembly is like assembly language. So are you talking about the same thing? Uh, Okay, I have not heard about this. I can look into it and like when we have some. Okay, what do you mean by assembly? Like, can you just describe it in a line? Meanwhile, I'll just look into that as well. Right. Okay, we'll just DevOps assembly. Okay, I do not know about that right now. I'll have to look into that. Yeah, but right now I cannot Google it. So I will try to find a perfect spot where I can just look at these things. So let me just such as CI for that infrastructure provisioning. Blah, blah, blah. Okay, I'll just see into that. Okay, I'll just look into it afterwards. By the way, the second session I have, which is on cloud deployment models, is it with you guys only or is it with some other people? The session at I guess 2:30. Okay. All right, all right. But I will just talk about these things because this is something that they should know about. So DevOps is the philosophy. Okay. All right, all right. So what I'm going to talk about is I will talk about these things in brief, and I'll talk about how do you understand these things from a developer's perspective. So when you look at from a developer's perspective, how are these things helping you, and how are these helping you actually make sense of the cloud computing environment? So the first thing that I would like to know is what do you guys understand by cloud computing? Again, when I ask this definition from a lot of people who are like experienced, like when I go to train people who are like who have like 5 years of experience or at least 6 years of experience, they give me very varying definitions. But when I ask like students like you guys, you actually give me the proper definition. So I would like to know what do you guys understand by cloud computing? Like, can someone write a small definition, or can you just open your mic up and say it out loud? Yeah, that's one part, storing and accessing data over the internet. Other things? You can actually do Google search as well because cheating is allowed here. I'm not saying that you cannot cheat. If you just give me some proper definitions, nobody's, yeah, that's one thing as well. Virtualization of data resources. Yeah, that's kind of a subset. Shared pool of computing resources. Okay. Yeah, yeah, exactly. That's what happened as well. That I went to another IBM institute and they had a standard definition from like NIST, which is a good one. Okay. Yeah, that's a good definition. Okay, we can stop now. We can stop now. We have too many things in the comment pool. So, uh, okay, so the definition that Rahat has given is the actual conceptual definition. Okay, an IST definition by Soumya. Uh, okay, at a flat rate or at a like pay-as-you-go model launcher. So the thing is, you guys can look at the definition given by Rahat. So it says the cloud is just a metaphor for the internet. So what it means is like what happens is when you talk about cloud, cloud is just a metaphor for the internet. So the thing is, when I talk about cloud computing at a conceptual level, it's just actually so if I have a computer and if I connect it to the internet and I allow users to connect to that computer and do some computational tasks on it, this is the basic example of cloud computing. So the thing is, I've seen it in a lot of, so I'm a consultant as well. So a lot of people have contacted me, a lot of companies, and they say that they have a cloud offering. So their solutions are providing cloud computing resources. When you say about what do you mean by cloud computing, what they say is that one example of a company that he said like we have 10 servers deployed in Hyderabad, they're connected to the internet and everyone just so everyone can just connect to it and like do their computational tasks. So exactly that is what cloud computing act is at a conceptual level, that if you connect a server to the internet and you do some computational tasks on it remotely, this is the basic format of cloud computing. So when you talk about servers, they are so this definition is kind of like what some of you have mentioned, that a practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or a personal computer. So this is what cloud computing is. But if you look at all the things that have happened so far, for example, since the beginning of the internet started with a client server architecture. When I say client server architecture, that there was a server which was remotely present and people used to go and connect to it and perform their tasks on it. So the thing is, when I talk about cloud, this term actually, the way that people have mentioned this term, it's because they came up with a new model of utility computing. So when I talk about utility computing, it means that there's a provider. He provides you with a lot of hardware or so, like hardware resources that you can use on a rental basis on the internet. So the current model or the current era of utility computing is cloud computing. It's no different from what was started when the internet was like at its earlier stages. The only thing is how do you actually implement this model? This is what has changed, and this is what has marked the era of cloud computing. So this is a definition by AWS. So AWS says that cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can actually access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like AWS. Okay, from a research background or from a educational background, I would like to say one thing, that the basis of cloud computing is made from something known as software-defined data centers. So software-defined data centers has three things. One is computational power, second thing is storage, and the third thing is network. So when you talk about infrastructure as a service or the basic things that a cloud platform provides, it provides you with three things: computing power, storage, and network. Above that, when you talk about databases, you can like connect computing power with storage, install a database, and use these things to work on it. So at a cloud computing, at the basic level of cloud computing, that a cloud computing provider, in a nutshell, provides you with computing power, storage, and network, and they can provide complex resources over that as well, like a database, which uses all of these three things. So when you look at a database, which is on a remote thing, it needs a network, it needs computing power, it needs storage. So we'll talk about that afterwards as well, but currently we'll stick to that. Now the thing is, what defines this era of cloud computing? Okay, sorry about this. Is again the definition that is provided by NIST. I'll just open that up. I thought I had it open up. So, all right. So I think you guys are very familiar with this NIST definition of cloud computing. This is a document provided by NIST, which gives you a definition of cloud computing here. I think you guys are very much accustomed to this, or you know it. Have you seen this document before? Have you guys seen this document before? No. Okay, so this is the NIST publication. You can just Google NIST 800 and 145. So this is the publication number. So I'll just give you a brief overview of this document as well. So the thing is, cloud computing actually emerged out as a term from HCL or somewhere. AWS was the first one to actually, Google was the first company to actually say something about cloud computing. They said it in an interview in 2006 that they are coming up with something which they are referring to as cloud computing, and it will provide some kind of resources. And AWS was the first one to actually come up with cloud computing. Okay, now the other thing is cloud computing became a marketing jargon. So people were exploiting this term. So everyone had a different definition of cloud computing, but they all said it was cloud computing. So what they did in exploitation, that if you look at someone like Red Hat was giving a definition of cloud computing that you can put up a lot of Linux servers on the internet and people can connect to those remote Linux servers and perform their computational tasks on a on-demand basis. AWS was saying something else and everyone was saying something else as well. So when you talk about government services or any government agencies, they want to have a non-ambiguous definition of anything before they put it in official terms. So the government of US, what they said that they had to use a lot of cloud computing software, something like that. So sorry, they wanted to shift to cloud computing model. So NIST is a body which is the standard body of USA. So this standard body was actually forced to come up with a definition of cloud computing. So they came up with this definition so that the government of US can use this definition as a reference and actually take up projects or deliver or give projects to contractors on cloud computing. Now, this was released in 2011, and this is the essential characteristics that it says that the current state of the art. Okay, if you look at a cloud service provider, they should have these five things to be called as a state of the art cloud service provider or the modern cloud service provider. One thing is on-demand self-service, broad network access, resource pooling, like a lot of you have said. Rapid elasticity means that it should go up and down, that I will talk about sooner, very, very fast, and it should be a measured service. Now, they have talked about a lot of things. The problem with this thing is they were forced to do this. So the thing is, when you look at these definitions, this is the only standard body which has given a definition of cloud. Now, the thing is, these things might not match everywhere because this was given in 2011 when cloud computing was relatively new and people were still exploring and people were trying out to find ways which are more profitable for the clients and for the developers as well. So there are some things which are very badly described. So one thing is deployment models. That is the second thing as well. The way they call the community cloud, nobody uses it, and people were really, really angry. Like, why do you put this thing here? We'll talk about this in the deployment model session, but that was for it. And other thing is like the service models have evolved as well, and there are many new things in the essential characteristics as well. So I'll just giving this as a reference. So the thing is, the only benefit of this thing is that when you're talking with people on what is cloud computing, this is the only standard body which has given you a definition. So if you use this definition, nobody can prove you wrong. But if you like give any other definition provided by any other service provider, it's not an issue. You can like still talk about that, and nobody will actually like say anything bad to you as well. All right, moving on. DevOps. So one thing is that uh, okay, what do you guys know about DevOps? Like anything that you know about DevOps, or have you heard about thing? Okay, so this is the thing that people normally put up, but this is not the actual definition of DevOps. Whenever you search for DevOps, you will see this thing. But so you can see that there's a developer and operations team as well. So I was going to talk about it from a development perspective. But before I do, I want to know one thing from you guys. Like, what do you actually understand by DevOps? People who have heard about it. development and operations going hand in hand, which is this diagram. Okay, any other thing? All right, it's fine as well. Kind of like automation. Okay, that's fine as well. So DevOps, mm, okay, that's Sridhar's definition is very close, but it's not completely close. So I'll just start with this now. So when we talk about DevOps, so there's a book which is called the Phoenix Project. This is a fictional novel. Okay, so the people who came up with DevOps, these people were really, really like they did a lot of contribution to the DevOps community. So one of them is Gene Kim. So in this, they have written a kind of like a fictional novel. So not all the things are fictional, but it's mostly fictional characters. So if you read this novel, it talks about how people came up with DevOps. And if you read this, it actually describes you what DevOps is like in a very perfect sense. Now, I would really like you to actually read this novel. Each and everyone of you should be should read this thing because the thing is, DevOps came up to solve a issue. As students, you are not. I don't think you will ever be able to understand what problems were there unless you go in a corporate environment and you face those issues. But with DevOps, those issues are gone as well. So I will highly recommend you to read this book, which is the Phoenix Project, and this will help you understand DevOps and cloud computing and everything else in a very better manner. So now when I go back here, so the actual definition of DevOps or the actual thing in DevOps, which we can understand from this book, it is not about only development and operations. So the problem this book actually shows is that when you are in a company, there's a lot of politics. So there's a human resource team, there's a development team, there's an operations team, there's a testing team, there's a project management team, and there are a lot of different teams. Now, if you might have heard in a company, there's a team which is for developers. So all the developers are present in that development team. When you talk about operations, all the operations people, so if you are not aware of, so operation people are the IT people. What they do is they put up your EC2 infrastructure up. They put up your infrastructure up. They actually ask for the servers. They set up your networks. They set up your firewalls. All the infrastructure level kind of thing. It's what the operations team does, and all the development is what the development team does, and so on. The security and testing team, they do the testing and see if when you deploy a code on your infrastructure, is it working or fine or not. So traditionally all these teams were different, and people from the same cloth, they used to be in all these different teams. Now when I come up with a project, so the main criteria about a business is to earn money. And when you talk about earning money at the basis level, the first thing that anyone has to do to earn money is to sell a software or to sell a software. So the thing is, softwares or applications, they earn you money. All the other things which are related to services, they help you provide infrastructure in which you can develop or deliver these applications or software at a very faster rate. So the primary thing which gets you money is a software. Now, when I come back to this thing, a software is a project. This software is developed by the development team. It's deployed and delivered by the operations team. The budget for this software is considered by the HR team, and how this software will be delivered, what will be the deadlines, and how many time you actually make it or something like that. That's taken up by the what do you say, the project management team. Now the problem is that when you talk about a project, even from a developer's perspective, all the different teams are involved. Now one thing that happens is when you're in a single team, you normally sit together. So a single team has more unity. And when you talk about different teams, or what different teams does is that they create silos. So one example is that you can consider this to be a development team and this to be an operations team. So the thing that happens is that they rarely meet. So a team normally sits together, but different teams, they normally do not sit together. They might meet up in specific cases, but they normally do not meet up every day. So the thing is, they are Raman Kumar. Now silos. is a concept to say, it's a concept to describe this thing. So traditionally, when we say about silo, there was a silo of developers. All the developers are in this silo. All the operations people are in this silo. To connect these people, and they are doing things differently. So the problem here is the developers, they are not talking to the operations team. So the operation team doesn't know what the developer needs, and the developers don't know what kind of infrastructure the operations people are doing. So the common excuse that I think you guys might have been saying as well, that you wrote a code on your own laptop, but when you give it to the lab computer or something, so I'm talking about a project. So you did a minor project or something, and or maybe that was a coursework or something that you had to do. So you wrote the project at your home, and when you come and give it to your invigilator or the teacher or someone, and they try it on their lab environment, it doesn't work. So the normal excuse that people see, that it worked on my computer. So this was the biggest thing, that was the difference here, that the developers used to say that it worked on my computer, and the operations people used to say that it's not working on their infrastructure. So what the solution was, that people came up with DevOps, in which the founding people said that rather than creating silos or teams on the basis of development, operations, HR, or anything else as well, we'll create a single team for a project. So when we take up a project, all the people who are related to that project should be in a single team. So if I am coming with the project A, the people for from HR team should be in that team as well. The people from project management should be in that team as well. The operations people should be in that team as well, and the development people should be in that team as well. So what I'm saying is, in DevOps, people say that you have a single team. You have all the developers, operations, and all the people in that team, rather than having a development team and operations team. So this was a basic thing of DevOps. Now the name DevOps comes from the place is that there was a guy, so a lot of things were happening between 2006 to 2014. Now this guy, he wanted to get all the people together and discuss on the ideas, which are these ideas. So all these ideas, they came up in the period between 2006 to 2014. So he wanted to put together all of them and discuss on this idea. So he created a conference, or he started a conference which was called DevOps Days. So the name was DevOps Days because he thought the name is cool. Because all of them, they came on DevOps Days and this discussed their ideas. They all the ideas, they grouped together in a single thing, and they called it DevOps because they came in DevOps Days, and they thought that the idea was cool. It has nothing to do with only being with development and operation. It tries to include all the people related to a single project in a single team. That's what they wanted to do. To understand why they wanted to do, you will only understand it when you read this book, because this book will give you a clear understanding of what was happening. Now, coming back to this thing, now the term that they used, because it was cool, DevOps, it gave a lot of wrong impression to people. So people thought that it only deals with development and operations. So this is why I'm talking about DevOps, is that because when they started talking about DevOps, people thought that development and operations team should come and sit together. A lot of people who are misguided, they thought that a single individual should do development and operation as well. This is happening in a lot of companies in India as well. The whole point of talking about this is to talk about the current scenario in India. The current scenario in India is that not big companies, but a lot of companies are thinking that when you talk about a DevOps engineer, this guy should know how to develop applications and how to deploy and do the operation task as well. So this is what I want to tell you as well, that you guys, because of this misconception, you guys will have to learn about development concepts as well, and you will have to learn about the cloud and the operations concepts as well, because of the misconceptions by people. Now Microsoft and Google, like from like 2 or 3 months, they're trying to come up with softwares that will segregate development and operations again. They want to say that developers should do development and operations should do operations. Operations should know what the developer is doing, and developers should know what the operations people are expecting. But currently, for the next few years, you guys are still stuck with DevOps, in which you should be able to develop and deploy the code as well. So by the way, this is an example of a CI/CD pipeline. So this says that this is the task of a developer and this is a task of an operations person as well. So you as a student right now, you will have to learn how to code, how to build different things, how to test them, how to release them, how to deploy them on a cloud-based architecture or on a micro containerization-based architecture, and then you have to operate and monitor as well. So this is something that I'll talk about when I in the later half of the course as well. That what are the things that you all have to learn and what are the things that you are expected to learn in the current time. But if Google and Microsoft are successful in their new propaganda or something like that, we will have development different again and operations different again, but not at the current state of the time. So this is what DevOps is. One more thing that DevOps does is it talks about automation. Have you guys seen the waterfall model? Yes. Have you seen this thing, agile sprints? Yes. Okay. So the waterfall model is a model which people used to use at the first thing. So it says do requirements first, then do design first, then do development first, then do testing first, then do deployment. Okay, it's development and then deployment and maintenance. So the thing is, you do one step at a time. When that step finishes, you do a second step. Then you do the third step, then you do the fourth step. So the problem here is that if you are at the deployment stage and you see that your deployment is not actually confirmed. Okay, so you thought about something at design stage. When you're deploying it, you learn that where you have designed is not something that you can actually deploy. This might happen to you guys a lot as well, that you planned for something, but when you try to work it out, it didn't turn out to the way that you wanted it to turn out. So the problem here is that you spend like 3 months still here, and on the fourth month, you realize that all your work was done in vain. So this is why people came up with the agile sprints, that you do everything in sprints. So this is a 2 weeks plan. So you do all the steps related in one sprint. So you realize whatever you're doing is working or not, and you have continuous feedback that lets you go forward. Now the thing with this is that again, these are like sequential steps. They have been divided into small sprints, but they are still sequential. So DevOps came up with a shift left movement. I didn't get a proper diagram, but this diagram is not actually correct. But what it says that if you consider this to be a timeline, this is the thing which is done first. Then after a day you might do this. Then after a day you might do this, and so on. What DevOps and the shift left movement says that you do all of these things from day zero or day one. So what happens is when you talk about design, the shift left movement says is that from your experience, you create an automation pipeline that as soon as you start coding, before coding or before starting coding, you already have your test cases up and you have a pipeline. As soon as you save your code from day one, it gets deployed, not on a production environment, but on a development environment. So since what DevOps says is that all of the things that are in sprint, they became this is not how you do it manually. This is the pipeline that gets automated. So what you do is you develop something and all these things they automate and they happen at the same time as the development. Is this part clear? Agile says you do these things in a small sprint and sequentially. DevOps says that whatever you can automate, you automate in an agile sprint. So agile and DevOps, they do not counter initiate like counter or they do not try to counter or argue with each other. DevOps says whatever you're doing in Agile is fine. Just try to automate it so that it speeds up your things. Now, this is what DevOps is. So, are you guys clear with DevOps? The thing I want to say is that when you're trying to develop on a cloud application, because of DevOps, people actually want you to know all of these things. They do not want you to know microservice so much. But the thing is, when you're developing on a cloud environment, you should develop it in a way that it's best for containerization, CI/CD, and microservices. This will give you a better opportunity to actually get a job or go really good in your career field as well. Now, moving to the second thing, which is categorization. Do you guys, as I think you're from virtualization technology as well, you guys understand this diagram as well, right? So normally you see a different diagram for containerization and virtualization. This is a proper diagram which says how things are happening. So when you look in a cloud-based environment, okay, let us consider this is diagram 0, 1, 2, and 3. If I look at deploying containers on AWS, which of these things describe it in the most accurate sense? 0, 1, 2, 3. If I'm trying to deploy containers on a cloud environment like AWS, which diagram describes my situation most accurately? Okay, third, Aditya Raj is right in that sense as well. Okay, all right. So some people are saying second, some people are saying, okay, we'll just talk about it in a normal sense rather than a computing terms. So 1, 2, 3, 4. A lot of people have started saying 4. Some people are saying 2. I think this is what they're referring to because that's what I said. So the thing is, this diagram shows my current scenario as well, in which I am running a PowerPoint presentation. So I have a network thing in which I am connecting to you. Okay, let's talk about the GoToMeeting software. So I have a networking layer, I have a physical computer, I have a Windows operating system in which I'm running GoToMeeting and I'm running PowerPoint. So this is my current situation. Now, if I had a virtual machine running like VirtualBox or Hyper-V, okay, I'm talking about VirtualBox or how do you say that thing? Okay, type 1 and type 2 hypervisor. Is it type 1 or type 2 or is it type 0 or type 1? I think it's type 1 and type 2 hypervisors, right? Let's consider they are type 1 and type 2. So if I'm looking at a type 2 hypervisor, this is the scenario. So if I have a virtual machine up and running, so if I had like my PowerPoint presentation or anything inside this virtual machine or applications inside this virtual machine, so this would be the architecture. Now, if I'm running on my Windows operating system and I have Docker for desktop installed, if I have a Linux host operating system and I have Docker installed in it, yeah, okay, thank you for all that. So this is my normal architecture. So I do not have a virtualization platform. I have a host operating system. Well, actually, this is not my actual thing. So the thing which happens in virtual containerization is that my operating system is of two parts. One is a kernel and one is an operating system. So when I talk about Linux, Linux is a kernel. When I talk about Ubuntu, Ubuntu is an operating system. So when I have Ubuntu and CentOS, they are both based on the same Linux kernel, but the operating system part might be different. So what happens is operating system takes up most of the size, and your what do you say? Your kernel takes less of the size. So what happens is rather than having host operating system, it will be the kernel here, it will be the container engine here, and you will have the OS inside the container. So OS of Ubuntu will be inside the container. OS of CentOS will be inside the container. Outside, you will just have Linux. So this speeds up my container even more. So that is something else which people do not show in their diagrams. This is something that I have only found practically described in the Docker documentation. Other people are still not aware of this thing. Now, what happens in AWS or some other things as well? The thing is, when I'm talking about a container, can I run a container engine like Docker without an operating system? Yeah. So the thing is, OS, the files, okay, container is loaded, not booted. So if you go into privilege mode, that it can be bypassed as well. So the thing is, when you talk about kernel, okay, I'll have to talk about way more things than that for this thing. I'll skip it up. Aditya, if you want, you can catch me up after this session and I can just talk about into that as well. The thing that you consider at a higher level is that the kernel is shared between these things. And when you talk about layers, your operating system layers are inside this thing. I do not want to go into deep because I do not think that you guys are comfortable with containerization technologies that much right now. But if you want, Aditya, we can talk about the class as well, and I can just explain to you what really happens because I've done a lot of experimentations. Kernels, no, actually, kind of. So if you look at a diagram, it kind of looks like when they say online, so this is a kernel, and all the things are made above the kernel. So yeah, kernel files at a different place, and all the things, including your, okay, so if you talk about the paint software, it normally comes with the Microsoft 10, sorry, Windows 10 OS. But this paint software is not inside the kernel. So kernel have all the softwares or the drivers that are really that are very much used, like that are actually completely required to start up your system. All the things like your start menu or your these things, they are related, and they are come in the, sorry, they are come as bloatwares in the OS. So this is what there is. This is what we'll have to look at this point of time, because we have different things to consider. I cannot talk much on that as well. So I'll just continue from here. So when I talk about these things, when you work on AWS and containerization, the thing is that AWS doesn't have a single server. They have like hundreds or thousands of servers. So the thing is, all those servers, they have multiple virtual machines as well. So what happens is, firstly, on any cloud environment, you have a virtualization platform that creates a virtualized machine, and inside that virtual machine, you are running a container. So when people say that this is better than virtualization, this is the actual thing that they are using on a cloud-based environment. Now the thing is, they have something known as bare metal hypervisors. So it increases the efficiency of this thing as well. So the only thing that they do is you remove the host operating system over there as well. So the host operating system comes on this layer as well. So currently I'm using Hyper-V. So on my machine, Hyper-V is installed at hypervisor level. Then what I am calling as my host operating system, which is the Windows 10, it comes up as a special virtual machine. So when you look at this thing on this point of view, it increases your efficiency of applications again as well. But this is not something that you have to consider from a developer's point of view. The point of view that you have to consider on containerization from a developer's point of view is that when you write an app, you know about containers, right? Containers are isolated environment. So the thing that I say that it worked on my computer and it's not working on the same computer, on someone else's computer, it can be solved with containerization. Because if I write code related to with respect to containers, I am including all the dependencies inside the same container, and these dependencies will not conflict anything with the other container. So I will move on. I have something else in which I will come back to here and I explain these things as well, because it's already 12:15. We are running short on time. So this is something which I talk about CI/CD. So when you look at CI/CD and the DevOps diagram people give you normally, this diagram is actually of CI/CD. It's not of DevOps. DevOps doesn't have diagram. DevOps has something else, which are the 3 ways and 4 types of work. You can actually learn about them here. So that's a cultural philosophy. I highly recommend you again to read this book, because this will explain to you in a better way on how to write code for your application. Now, going back here, you'll have to learn a lot of things. I'll just talk about the places where you can actually look and what kind of things you need to know. So one example is like for code you can use Git or Jira or Trello or any other thing. For build, you can use code build, or there are other things as well. So let me just talk about the phases that you have here. When you're talking about code, you're talking about how do you write a code, and where do you save your code, and how do you manage that if you have like 10 people writing a code, how do they actually integrate all their code in the same place? This is what it talks about. When you talk about build, for programming languages like C, or if you look at React or any other thing, application that builds on the code. So all the building software, what they do is they take up a code which they understand, and they compile and build another kind of code. So if you look at C, you have GCC, which builds your C code into a running application. If you look at React, React converts JSX into JavaScript and HTML. Now, when you talk about test, you have Selenium and you have all the other things. You have unit tests and you have integration tests that you can do. When you talk about release, the thing is, when you write a code, you build it, you come up with an executable. So when you have tested that executable, the software which has been tested comes out as a release. So a thing which is ready to be delivered. So the primary stages here are build, release, and deploy. So when you talk about build, it converts your application in your code into an application. Release is after everything you have tested and you see that your application is working and it's ready to be delivered. It's what release is. When you say deploy, you actually run your code. You get a code here, you see that the code is working fine, and now the code is running here. When you operate, it's where okay, this is something else which I will not like to talk to you about right now, but Maybe in the future you learn it, because this is not something that you should look at at this point of time. When you talk about monitoring, there's a new kind of approach which is called a microservices approach. The thing is, rather than having a single application deployed, you're having like hundreds of application deployed. So you have to have a monitoring platform which actually monitors all those microservices, and at a centralized place, it shows you what kind of things that are happening with your microservices. Because the thing is, if you have a single application running, you see the console right there and then, and if there's an error, you can see that in my application there is an error. But if I have 100 microservices running, I cannot see all the prompts from all those microservices at the same point. The thing is, I need to have a monitoring software to actually get the logs from all the microservices, put them at the same place, and give me alerts if there's something there as well. So Prometheus is one of those things. Now, if I talk about this thing, okay. So if you go to this place, which is called cncf.io, this is a cloud native computing foundation. And when you go here, when you go to projects and you click on graduated and incubating projects, I'll share the link here as well. Here you can see a lot of projects that are being used these days. So you can see that Kubernetes is for orchestration, Prometheus is for monitoring, and other things as well. So there are a lot of things that are here. They all solve an issue. The thing is, when I started as well, it was this thing used to give me a lot of headache, and I never used to understand what these things are for. So what I did is I took up a single tool. These are the open source tools, and then I tried to find out how do they work in this kind of structure. So the thing is, at your stage, you will not understand what they are useful for. Just take up a tool, try to find out what it does, and like when you try doing these things again and again, when you're graduated, you will have a lot of understanding of what these tools do. And trust me, like when you talk about DevOps, people really want to know, like it will give you a really good boost to get a job if you know about these things, because the modern infrastructure which big companies are coming up with, they are all using these tools, and that's helping them with DevOps. So what I would like you to do, go at these things, try to look at projects. Like this will not come to you in a day or even a month. It took me like 1 year to get an understanding for all these things. So take a long period while you are working in your while you're still studying. This is something that will give you a lot of things to understand. Because when you talk about cloud computing is all about deploying applications. It's not about like what things do you have to deploy. So cloud computing talks about infrastructure as a code, and you can get up servers up and running. This is what tells you like when I want a server up, what kind of server I need for my applications to run as well. Now, do you know about the microservices architecture or a monolithic architecture or something like that? Like, have you heard about monolithic architectures and microservice architectures? Okay, this is a thing that is an advanced concept. The most highly paid DevOps people are the ones who know how to make microservices. I know a company which hired like 20 people with 4 years of experience, and they are getting 40 lakh rupees a year as a as a like what do you say, payment, or I forgot, like it's the salary that they are getting, 40 lakh rupees a year, because they are really good in microservices. So when I talk about microservices, these are all the things that will be required from the starting to the end to actually understand what microservices are. At the plain level, what it does, that have you heard about the application layers, that you have multiple layers in an application? You have a business layer, you have a logical layer, you have data access layer, you have a UI layer, and etc. etc. Have you heard about those things? Yes. The thing is, these are not useful at all. In a microservice architecture, you do not consider those layers at all. So what happens, whatever is in a layer, you actually create a service out of it. Okay. So the thing here is that in a monolithic architecture to a microservice architecture, rather than having a single application, you have multiple applications running. So again, a lot of people on online, they have a very wrong definition. They normally say that you split your application into multiple parts. The thing is, that is what you are already doing as well. If you talk about an application, you have modules, you have functions, and you have other things as well. So you're already splitting your code. The only difference which happens with microservice architecture and monolithic architecture is about processes. When I talk about processes, when you go to control or delete and you look at task manager, you can see that there's a exe files running. In a monolithic architecture, you have a single process running, which loads all your functions, all your modules, and everything else as well. When you look at this single exe file, if I have 10 or different modules which are being worked on by 10 or different people, if I put a semicolon at the wrong place, my whole application goes down. If I have multiple exe file running for each of these modules or each of these things, what happens here is that if there's something wrong with this specific microservice or the code in this specific microservice, this microservice will go down. And you can see that all the remaining infrastructure is still working. So if I have this application which is communicating with this microservice, currently this microservice is just using the UI and microservice. So this part will run. When you look at if this microservice goes down, then this will not work and the other things will not work, but some microservices will still work as well. So the only thing what is happening with this kind of architecture is that from a developer's point of view, if you are a developer, if you have a microservice code, and with this microservice code, now your code is different and your application is running at a different point of time as well. So let's consider again a new example. I am a developer which is running with this part of microservice and someone else is running at this point of microservice. So if this guy messes something up, only the code for this microservice will go down and this application will crash. This application will not crash. Now, if I consider these two things to be a module or function of this monolithic architecture, what happens if I am running this microservice, this module, and I'm writing and integrating code. So what happens is when I integrate my code here and this guy has done some mistake, the whole application goes down. So if I am not having a proper error message, I might think that whatever I have written in the code caused the bug to produce. So this used to waste a lot of time. So people came up with a microservice architecture. This is the end goal that you guys will have to learn if you're going from a developer's point of view. Currently, this session is more focused on the development models. So from a development point of view, this is your end goal right now. To actually come up with this architecture, you have to learn CI/CD, you have to learn containerization, you have to learn agile sprints, you have to know what DevOps is, and you have to learn cloud computing as well. So this is something that people are working on, and it requires everything that I've discussed so far. Okay, is that kind of clear? Again, if I want to talk about microservices and give you everything about that, I will have to take a complete day session on it, which is not the focus of these things. So I will tell you where you can actually learn about microservices and the next point of the training. Currently, this is all I am going to talk about here. But if I go on, this is another thing which you have to look at the developer's point of view. So the thing is, these two things are your end goals. This says that you create a microservice architecture. The 12-factor app, which was given by people at Heroku. Heroku was one of the first cloud service providers. People do not know it really well, but in 2012 or 2013, it was going really, really well because it gave you everything. It gave you CI/CD pipelines. It gave you proper interface to containerization. It gave you proper ways in which you can work with DevOps as well. The thing happened is that AWS, Azure, and GCP, they actually moved really forward of Heroku, but like 5 or 6 years ago, Heroku was a really big cloud service provider as well. I'll just type the name here. So the people at Heroku in 2011, they came up with these 12 things that you have to look into. So this is the primary thing that I wanted to talk about. All the things were like the basic things that you should know to actually come up with this thing. So when you talk about code base, this tells you that at this point of stage, what you should do. So when I am talking about microservice point of view, each of my microservice should have a different code base. In my monolithic architecture, my single applications has a single GitHub repository. So if I have like 10 million lines of code, or if I have like 100 developers working on this application, in a monolithic architecture, I will have a single GitHub repository. In a microservice architecture, I have a code base. Each of my microservice will work with that code base. Now, one more thing I would like to talk to you about is this architecture. It came into being in 2014 and it gained publicity by 2016. This came out in 2011. So what happened? People started using this for all the things that I've talked to you about. So when I work with all these things, Then I came up with the microservices architecture myself. So the thing is, you will have to look into these things. So it talks about dependencies, explicitly declare and isolate dependencies, which are happening in the containerized environment. The third thing is config, store config in the environment, and all the other things as well. Currently, do not try to understand this at your level. This is not something that you will understand at your level, and this is not something Can you guys hear me now? Okay, cool. All right. So, at what point did you guys lose me? What was I talking about? Like microservices or 12 factor? 12 factor. Okay. So the thing is, these are 12 factor apps, and there's something which is known as beyond 12 factors as well. So a suggestion for you guys is you still have 3 years or like 2.5 years for your before you graduate. The thing is, whenever you learn about the cloud computing thing, you just go to the 12 factor app and you try to understand what it means here. So this is something that you will gain with experience. Take up a single technology. When you look at cloud computing, come back here and see, okay, so when you go to 12 factor app, again, I'll just show it to you. So when you are here, you can actually click on a link and it will talk to you at an abstract level what you should do. The thing is, again, this is like when you want to cover this, it takes like 2 or 3 days as well. So the thing is, you just go to this website, you try to read them, like make a list like that. Every week I come here and whatever I have learned, can I actually like look at some 12 factor point of view as well. So again, when I go about this 12 factor thing, that if you look at all these 12 factors and you write an application which is conforming to these 12 factors, then what will happen that you will come up with something which is known as a cloud native approach. A lot of people, they are looking at these things. So if you know how to implement microservices in this thing, the way that your career opportunities will go up very well. So the thing is, for example, it says that execute the app as one or more stateless processes. When I talk about stateless process, it means that I'm not storing anything on my application. I'm storing it on a backend database. So when you have to create your app in a stateless point of view, you have to write that code in your thing. So in a development point of view, you have to write an app which has to conform to these 12 factors. Now there are 15 factors. You don't look at 15 factors. That is something which is mentioned in a book which is called 12 factor, beyond 12 factor apps. It's a free book as well. The thing that I want you to do on your level right now is just look at these things
Whenever you're writing an application, try to write it in this kind of sense. This is not something that will come up to you at an instance. The thing that happens is when you look at these factors, whenever you learn these things, it will automatically click that this technology fits to this factor. So over a period of year or two, if you continuously look at these 12 factors and this thing, you'll understand to actually write something which is in a proper, or like what can I say, that it conforms to the best microservice architecture. So in a development point of view, this thing actually defines the way that you should develop your applications for the cloud environment. When you think about these things, only when you know about DevOps, CI/CD, and everything else as well, you can actually work with these 12 things. So I will not like to talk more about these things. I actually led you to a very confusing thing. So this thing, over the period of next 2 years, try to understand them in a better manner and actually do these things which I have mentioned here. So for you, if you want to get a like really good career opportunity or anything, you should know about all these things. Now, the first thing that you should start with is cloud computing, then move to CI/CD, then move to containerization and DevOps, and the last thing that you should do is microservices. To actually put it into a proper sense, uh, there's a trail CNCF. So this is something which is again confusing. Uh, can I read it? No, I cannot read it. Okay. Open image data. So this is our GitHub repository. It's from CNCF. That when you're trying to write applications for cloud environment, these are the things that you should learn in sequence. So it says that the first thing you should learn is containerization. So try developing applications which fit into containerization point of view. Then try to learn about CI/CD. Then try to learn about Kubernetes. Then try to learn about service proxy, service discovery, observability. They have given you some tools here as well. So at your point of like at your level, you should learn how to write microservices as well. But this is the proper way to learn them in sequence. When you are learning them in sequence, this is how you learn. This is not how you deploy. When you write a code, this is the things that you have to take into consideration. This is something which is the sequence of things that you should learn to actually go into a proper proper way in which you can write applications for the cloud. Again, this is something that you would expect from a person which is like 3 or 4 years of experience. But if you want to learn it, you can still do it as well. Now, is everything clear to this point? Like so far, whatever I talked about, is everything clear, or do you have some doubts? Yes. Okay. Now the thing is choosing a programming language. Because of containerization, because of fill factor apps, because of all the other things that you have had so far, there's something which is known as polyglottic architecture. Do you guys know what a polyglottic environment is? Okay, what I mean by polyglot is that a person who knows multiple things. So previously in traditional architecture, what used to happen that if my monolithic application is written in Java, so all the people who are relevant to that, all the developers, they should know Java. Because the thing is, when you execute an application from a single process, if I have written my starting application in Java, all the other components should be in Java. But what happens in microservices is that these are running as their own processes. Now I can use Python for microservice 1, I can use Java for microservice 2, and I can use a lot of different things for microservices. This is why there's something which has happened as well, that initially used to have a single database. It was MySQL. MySQL is a database which is a jack of all trades, it's a master of field. Now it happened because of the microservice architecture, I can have different stack for my different microservices. For example, if I want to work with a location specific data, I can work with Python, I can work with Flask, I can have a database like Neo4j, which optimizes in like location specific database. So I can have that. So if I'm dealing with location specific microservices, my Neo4j works with that. If I have structured data like your marking scheme, I can have MySQL database in this microservice. If I'm working with this microservice which is dealing with tracking data which is very unstructured, I can use MongoDB or CouchDB for that. So microservices architecture has allowed me to choose my programming language stack depending on the efficiency of that. Me myself, I work on this thing.
Can you hear me now? Guys, am I audible now? Am I audible now? Okay, I do not know what's happening. I just turn off my mic and start it again and I'm audible. So what I'm saying, because of the microservice architecture, in each microservice, I can use a different stack. I can use a different operating system. So I can, because of containerization, I can deploy this microservice on CentOS. Here I can deploy it on Ubuntu, because one problem that we normally face is that if you have written a code for Ubuntu, there are very less chances that it will work on CentOS or something else as well. Like there are very less chances that it will not work. I want to correct that. There are a lot of chances that it will work on any other Linux distribution, but there are like few chances that it doesn't work. So CentOS is different, has optimization for different thing. Alpine is another thing which has optimization for containers based environment. And there are many different operating systems that are coming up for one specific use case. Because of microservice architecture and because of containerization, I can choose technologies which fit more of my use case. So now I can work on Node.js, I can work on Java, I can work on other things as well. So when you want to learn anything from career perspective, because of my microservices architecture, you can have any kind of programming language stack that you want. But the thing is, Java with Spring Boot is the most commonly wanted framework. So I would say that if you like Java and if you like Spring Boot, a lot of companies would be willing to hire you. It's not like that that if you are learning Node.js or Python or any other thing, you are out of jobs. The thing is, the maximum number of jobs are with Spring Boot with Java in this kind of architecture. But if you look at Python, so if you want to go into operations and if you do not want to go into development, you can still learn something like Python, which has really good support for operations as well. So what I want to say is that the main languages that are happening right now are Go, Python, Java with Spring Boot, Node.js, and few more. The thing is, the language which is at top right now is Java with the Spring Boot framework. Then you have Python with Flask. Then you have Node.js with Express, and I do not know what is in Go. So the thing is, any framework that allows you to create an API is something that you should learn. So Python has a framework which is Flask, which allows you to create APIs. Spring Boot allows you to create API for Java. So any language that you want to choose, you choose a framework that allows you to create API and you learn that thing. You will still get jobs. It's not like that it's the end of the world for you. The maximum quantity of jobs are for Java and Spring Boot. So again, I'm talking about career opportunities. There are a lot of things that are happening. So firstly is that, okay, so the people who give you career opportunities or jobs are primarily the HR people. HR people are not technically inclined and they can be really, really stupid. That's what I want to say as well. Sometimes, if I am in a team, I just tell my requirements to our HR people. They conduct everything. They actually screen your CVs. They actually do everything else as well. And they are the first point of contact for you. So the thing is, currently, what happens is that for HR, everything is DevOps. For HR, cloud computing is this definition rather than an accurate definition. For HR, it can be different as well. So HR, they do not understand this at the level that you should be understanding it as well. So the thing is, this is good for you to develop things. But the thing is, when you talk to HR or when you want to do things or when you want to put something up on your resume, it's better if you put DevOps and if you put these key terminologies rather than putting that you work in cloud native things or you work in 12 factor app or other things as well. You should put them on your CV. But the thing is, most of the things that are mentioned here are what HR consider things as well. So these are the things, these are the keywords. I do not know what's happening here.
Can you hear me now? Yeah, the thing is, I have two microphones. One is in my headset and one is in my computer. GoToMeeting is automatically shifting the microphone to the other microphone, which is not working. So, okay, going back here, the thing is, when you go to a career opportunities or anything, the primary thing that they talk about HRs, they will talk about these five things. So these are five things are the what do you say, like the buzzwords that HR know. So try to put them up on your CVs. Then whatever you have learned, you put them afterwards. Now there are multiple things that happen in as career opportunities. The first thing is I think this is the best diagram to show it. So when you talk about DevOps, a lot of people, they actually in India, they do not know what DevOps is actually, and they think that you should be able to know all these things. So when they hire you, they make you do all these things. Good companies or bigger companies, what happens in career opportunities point of view is that even if you know cloud computing or certain set of that you know how to deploy on Amazon or Docker or something like that, they will still hire you. It totally depends on the HR and other thing as well. So again, for career opportunities, I'll go from the base thing. Okay, so the thing which happens is that I go to a lot of conferences. I talk to a lot of people who are like really big positions. They have told me one thing, that when they are trying to hire people who are freshers, they expect that you do not know anything at all. They just want to have someone who is willing to learn and who has a good learning, like what do you say, growth rate. So the big people at companies, they say that we are trying to look for people who can learn things and who can work well as well. The second point of thing, that people who are more like what do you say, in a teamwork kind of sense, they actually try to prefer those. So the thing is, I'll give you an example that I had a person in my university. He was really good with everything, but the thing is, what he was not good with was the people's part. So he was not good at team working, but he was really good with actually deploying applications. So a lot of companies, they actually didn't give him an offer, because the thing is that when they hire you at a freshers level, what they are trying to expect from you is good coordination. The thing is, not all people, they want the best person. What they want to do is, if they hire a person, he should be able to understand and he should be able to work with other people in collaboration, and he should be able to come up with solutions which are very agnostic, and he should not be like very anxious or something like that. So the thing is, a lot of companies, they are not looking at that you should know everything. It's good if you know something, but the thing is, they will train you. The primary thing that they will look at is if you are able to learn and if you are able to listen to them. The thing that they want is you to be able to listen to them. So the thing, this happens only when, okay, so if you come up with some technology and if you are learning it, and if you do not know anything about this technology, and if you do not know where this will take you, that will make you anxious and it will make you less susceptible to listen to anyone. So the thing is, for the next 3 years, if you actually come up with something that you actually are aware of these technologies, so this, when you're comfortable with these technologies, it will make you less anxious. And when you're talking to someone, it will make you more able to listen to things and what people are talking about. So again, from the top point of view, big management people, they have openings which are dependent on them. So they might come up that they need developers, or they need someone who actually deploys this application. They need someone who might do CI/CD, or they might have different career opportunities that they might come up with you as well. The thing at your level, what they are trying to do is, when they come to you, the base point is that you should be able to understand, that you should be able to learn. But the thing is, if a company comes to you and they have 20 openings and you are like 114 people, out of 114 people, I would say that there would be 60 people that match their criteria, who are able to understand, who know, who have good communication skills, and who can learn. Now the thing is, between these 40 people, they will choose people who know these technologies. So the thing is, firstly, the management people or the people at the higher level, they do not expect you to know anything, but they would be happy to teach you. But these are not the people who are coming to hire you. The people who are coming to hire you are the HR people. When they come to you, the first thing that they see is if you are able to learn or if you are able to communicate. Now they know 40 people who are able to do that. Now they have a openings for only 15 people. Now they will start judging you on what things that you already know. So this is where that when you learn these things and learn more of them, this is your chance to shine. What will happen is that again, different companies have different requirements. Some people might want you to learn Jenkins. Some people might focus, for example, on Git. Some people might focus on Terraform. Some people might focus on Docker. It is totally upon them. So you should not do this thing that you try to learn all the software system. The thing is, it's totally on your luck that if you work a lot with Docker and a company comes who wants to work with Docker, so they will hire you. But if for someone that this company wanted you to know Git or Jenkins or maybe like Selenium, and if they come and you knew these things, they will hire you. So the thing is, try to learn as things as much as possible. The core things that you should learn here are Docker, Amazon Web Services, Jenkins, Git, and some testing framework. Other things are not normally expected from you. So prioritize on these things, then go to CNCF projects, look at all the projects that are there, and then try to put them up here to actually increase your chance of getting hired. So again, the thing is, firstly, you need to be able to learn things. You need to be able to be stable in your life. The other thing that happens is a lot of different companies, they will have a different architecture or they will have a different thing that they want. Because again, when I talk about the polyglotic architecture, now because of that, different teams, when they are hiring, they might look up at different technologies. As a human, it's not possible for you to be always be ready for the career opportunities that are there, because of the polyglotic environment, the career opportunities are way much like where you cannot categorize them that you have a lot of career opportunities in AWS, you have a lot of career opportunities out there. Well, you can actually do that for these two specific technologies. But the thing is, when a person comes, they might have their own stack that they are looking for. So what they will do is they will have a checklist. First thing is, again, I'm talking about this again and again because this is what people forget. The thing is, you should be able to learn and you should be able to talk about things that you can. And from top of that, I would like you to learn Docker, Amazon Web Services, Jenkins, and Git at a basic level, and take up a programming language. Spring Boot is a good programming language that you should take up. Otherwise, if you do not want to take up Spring Boot, Node.js, Go, and Python. They are the three languages that you should look on. So the Mern stack or the Bean stack is what is good in Node.js and other things as well. So again, are you guys understanding? Because again, I'll just type it down here. Ability to learn. Then okay, I cannot. Okay. First thing you need is the ability to learn. Second thing, you need to know about the base technologies, which are these four things. So cloud computing, containerization, DevOps, CI/CD, microservices. So for cloud computing, pick up a provider like AWS. For containerization, pick up a provider like Docker. Read the Phoenix project book. That is the only thing that you need to know about DevOps. You should be able to talk about DevOps. Nothing more is needed about that. For CI/CD, you can take up Jenkins, and for microservices, that's a completely different thing. So you can look at like 12-factor wrap if you want to do that. So these are the things that you can focus on right now as a student, and these will give you more opportunities to get a job. Now back again here. By the way, highest paying jobs are with microservices. Now when I come back here, what was I talking about? Okay, yeah. This is the diagram that I was talking about. Now this is something that you should learn at base level. 12-factor app is something that you should not know completely. But if you know Jenkins, if you know Docker, if you know AWS, then again back to the point where 40 people have shown an ability to learn, and out of that they have to like take 15 people. They will take it on the basis of these things. So the primary or the most common things that they will look into are these things. If you are good with them, you will have a higher chance of success. So this is what I'm saying, that normally as a student, you should not go like you should not think about that you should be able to learn everything as you should know everything, because Kubernetes is something that I will elaborate in the second session. Are you guys will be with me in the 2.5, like the session that we have at 2:30, or is that a different batch? Okay, okay, no different batch. Okay, so I'll just talk about Kubernetes here as well. Okay, when you are developing things, you do not talk about Kubernetes at all. When you learn Docker, you learn about containers. Yeah. The thing is, when you are developing, this is the new approach that Google and Microsoft are promoting. That okay, so the thing is, if I'm a developer, as a DevOps guy, they are expecting me to learn Git. They are expecting me, okay, Git takes like a week to get accustomed to. You can say Jenkins takes a week to get accustomed to as well. Amazon Web Services, if I want to be really good with them, it will take me 6 months to a year. If I'm learning Docker, it will take me another 6 months to get comfortable with it. So as a developer, are they expecting me to spend 1.5 years to learn these things and then another 6 months to learn Kubernetes? That is not something which is feasible. So as a developer, I am only interested in learning about Git, only interested in learning about Jenkins, something to do with Selenium or something unit testing or something like that, depending on my code structure. And then they are expecting me to learn Docker. So when I talk about Dockers, I should be able to deploy, I should be able to write a Docker file which creates a container that runs my microservice. So this is something that people or developers are supposed to know. What Kubernetes does is it takes a container from a Docker person. So all the developers, they work directly on containers. So they work with Docker, they do not work with Kubernetes. They will work with Docker, they create containers of this application and they make it deployable. Now what Kubernetes does is I have 10 containers. Kubernetes or OpenShift, which is like Knative or something like that. Let's just leave OpenShift right now. Let's just talk about Kubernetes. So what Kubernetes does is it runs 10 slaves, which are like on like 15 machines or something. Sorry, I have 15 machines and I have like 10 containers that I want to deploy. So what Kubernetes will do is it will see what it will do health checks on all my 10 machines, and it will see of on which server do I have some free resources. So what it will do is it will deploy my containers depending on the requirements they need, and it will put up all the containers of that stack in the single machine. So what Kubernetes does is it just manages my containers. So I have multiple servers, I have a cluster of servers. My Kubernetes will take up a container. If I have a stack of containers, for example, using Docker, I am running 2 or 3 services which should be bit together, which should be very close to each other. So that is something which is called a Docker stack or something. So my Kubernetes will take all these 3 things. It will find a server which has resources and will deploy it over there. And if that server goes down, it is the job of my Kubernetes to actually like if my application goes down, my Kubernetes will if my container goes down, my Kubernetes will have the job of polling that container again and again, and then if it goes down, it will if it's because of the server, I'll remove that server, I'll take up those containers and I'll start them on another service. That's what Kubernetes does. So from a developer's point of view, you do not have to learn. Yeah, it manages containers and deploy containers depending on free spaces. Yeah. So you have like, I didn't have the diagram here. I can show it on Paint in a better sense. So I have like 3 servers. These can be 3 virtual machines. Now I will tell Kubernetes that I have to deploy a stack of containers which has 3 containers running. Okay, this is not what actually happens. I'm giving an abstract thing. So these will be 3 pods rather than 3 containers or services, which again you will have to know like the 12-factor app to understand what Kubernetes is doing. Now, what we will do, these 3 containers are supposed to be very close to each other. So Kubernetes will try to find a VM which has available resources and it will deploy it over there. Now, if this VM goes down, my Kubernetes will sense that this VM has gone down. So it will try to come up here and deploy it here on other available resources. So Kubernetes, what it does, it just manages my containers. So the thing is, when you talk about containers, there are a lot of things. If okay, the thing is, I cannot talk about that right now. But when you try and look at the 12-factor apps, like if you talk about store config in the environment, it is very containers are always isolated. That is, if you want to know how Kubernetes manages that, that is not something that I can cover in like 5 minutes or something. You will have to learn Kubernetes yourself. The thing is, Kubernetes has pods in which you have, like ideally you will have one container, and you will have multiple sidecar containers. Again, I do not want to go deep. So the thing is, if I talk about few things, okay, I'll just give you a very simple example. It does more than that, but the thing is, so I have a VM and I have a VM, okay, right? My okay, I mean just using Docker right now, not Kubernetes, just Docker. Using Docker, I deploy containers manually here. So what happens here is that when this container gets deployed here, again, which port it works on is something that I do not know. So there's a thing which is known as service discovery. What it does is whenever my container comes up and this application is running on that container, what service discovery does is it records what IP and port my container is running on. Right? Now, if another container comes up which has microservice, I'll use the name of that microservice and I can connect to this. This is very analogous to a DNS server. You know what DNS are? That there's a DNS server. I know there's a website known as facebook.com. I do not know where it is. So I'll just call my DNS server saying give me facebook.com and it will give me the IP of that. So service discovery is very similar to that. Rather than just IP, I will have port as well. So as soon as my container or my application goes up, my application will register that in service discovery, and whichever service wants to use this application, it will contact service discovery and it will give me the IP of port of that application. I'll connect to it. Now the thing is, whenever my container goes up, my container has to contact service discovery. This requires me to write code. The thing is, as a developer, I want to isolate this code from my application. So what happens is that you have two containers which are not that much isolated. So the thing is, Docker isolates things completely, but in these kind of containers, container one and sidecar container, I'll have my application code in one machine and I'll have sidecar container, which will take up this redundant code. So the thing is, with Docker and containers, I have to care about this redundant code. Now, if I'm a DevOps guy, I can write this redundant code. But if I am just a developer, as I should be, I should not be considering this code. So what happens in Kubernetes that I write code which is just for my application. This code goes in container, but all the code that is required for me to actually go in and follow these 12-factor apps, that code will go in my sidecar container, which an operations guy will write. So this is the integral unit of Kubernetes, which is called pod. So I have sidecar container, which manages my containers. If I just use Docker, I will have to write all this code in my container. If I use Kubernetes, my sidecar container will do everything for me. For example, there's something which is known as store configuration in the environment. So configuration settings is like if I written an application and if I want to connect it to a database, the thing is I need to have configuration which says which IP and port it should connect. Now the thing is I do not know when my container starts where my DB is. So normally I have to write a code which actually when I'm starting a container, it will give my application where my database is and what IP and port is. Now this thing goes into sidecar container and Kubernetes automates this process and makes it simple. So this is what Kubernetes is. So the thing is, my suggestion for you is Kubernetes is not useful for you at all. First learn Docker containers, then learn CI/CD pipelines, then try to learn 12-factor apps. Kubernetes helps you solve a lot of these 12-factor apps and tries to automate them. In Docker, you have to do it manually. The thing is, first try to do them manually, because when you try to do it manually, you will get stuck in a lot of situations, and then you will realize what is the value of Kubernetes. So is that clear? So what Kubernetes does is, in Docker, I have to take care of these things myself. Kubernetes helps me automate these things. Now going back to this thing for your career opportunity, the thing is, normally the stack that people normally look at is, you should learn Git, you should learn any testing framework. This testing framework depends on your language of choice. So if you are using something like Spring Boot, Selenium is good. If you're learning Python with Flask, PyTest is good. And for build things, I don't think you really require a lot of things for Java or something like that. But Jenkins does your so Jenkins automates all these things. So Jenkins is not just at release. Jenkins automate it from code test to release. That you will see from there. A new tool, if you Jenkins is the most asked tool. But if you want to look at a new tool, and if you want to see what it does, there's something known as Azure DevOps. This is the best tool for CI/CD or for everything here as well. When you talk to, I looked up at assembly pipeline. Assembly pipeline can be completely achieved with Azure DevOps. That's what I'm thinking so far. So Azure DevOps is a new thing. It's a thing. It's not a. It's actually deployed on the Azure cloud environment, but it's cloud independent. You can actually write all the code, build CI/CD pipelines for your AWS system. So if you want to learn something new, Azure DevOps is a good thing. If you want to learn something that will give you a job, Jenkins is the thing. And if you want to learn things which gives you a job, Docker, Amazon Web Services, and other things are as well. So first thing for career opportunities, learn Git, learn PyTest or Selenium, learn Jenkins, learn Amazon Web Services, learn Docker. And at this point, after you have learned them, you just go to the CI/CD trail map. You look at the high level things and you learn them in that sequence. So as you can see, Kubernetes is at the third point. Before that, they are asking you to learn CI/CD pipelines and containerization. So CI/CD is Jenkins, Azure DevOps, and another company whose applications will let you get jobs is that there's some company known as HashiCorp. So it has a lot of tools, which are these tools. So these tools are required by the industry again as well. So there's a lot of career opportunities for people who know these tools. But again, these tools, you should not learn them right now. What I want you to do is, I want you to wait a minute. I think there's one thing as well that I missed. So this is a place where they have described about the tools. So the first thing that you do is you learn the landscape, or you learn the trail. Where was it? I should not close it all the time. Okay, so this is your learning map. When you go to containerization, go to this link, which tells you all the things that are for containerization. For example, can you see containerization somewhere here? Can I search for it? No, I cannot search for it here. I guess. Okay, this is not the thing that I wanted to see. Okay, the thing is, when you talk about containerization, when you go to the landscape kind of thing, it would be somewhere here. I'm not finding it right now. I cannot see it, but it will tell you all the things that are related to containerization. So you can look at the multiple things as well. So the CNCF project, which is for containerization, is called Containerd. That is what Docker utilizes in itself as well. When I look at scheduling and orchestration, you can see that I have ECS, which is an alternative to Kubernetes. I have Nomad, which is also an alternative to Kubernetes. I have Docker Swarm and other things as well. So ECS is something from AWS. Service Fabric is from Azure. Nomad is something from HashiCorp. This is something which is something which goes really well with Kubernetes as well. So you should not get overwhelmed by the lot of technologies. Go to the trail map, look at and pick up only one technology. For containerization, just pick up Docker. For CI/CD pipelines, try to pick up Jenkins. Otherwise, you can choose like Argo, or there are a lot of things that you can choose. So there's Circle CI, there's GitLab, there is Jenkins, there's GitHub Actions, there's Clean City, there's Travis CI. There are a lot of other things as well. So this thing, which is this landscape thing, will help you find tools that you can learn. So this is where you learn things from, and this is where you deploy things. The core part of all these things is your CI/CD pipelines. And one more thing that I want you to do is always look at full factor app. Okay, from the bottom, try to start learning things from here. Pick up tools from here, and try to see if where do these tools fit in, and learn about them. So microservices will come automatically to you as well. So this is one slide that I would like to show you here, that when I talk about how tall are you, this is one thing that was given by an organization, that when you want to learn microservices, first learn about cloud computing and infrastructure as a code, then try to learn about monitoring, and then try to learn about deployment. What I mean by here is that after you have learned these three things, Git, Jenkins, Docker, Amazon Web Services, and Prometheus, then you can actually look at 12-factor app, and you will try to, it will give you a better approach of how to do these things as well. So when you're writing applications, look at these things, use these tools, and then go to this trail, then try to learn them as in the same sequence, and just try to know about the tools which are the alternatives for that. So this is something which will help you get career opportunities, because this is something which organizations are looking forward to. All right, so any doubts so far? Because the thing is, we are running out of time. The thing is, the last thing, which is Q&A. In this Q&A, if you have any doubts so far, you can just ask me about that. You can ask me about career opportunities. You can ask me about anything that I have covered in the slide, because normally I would have preferred that there would be something like more than 2 hours, but yeah, that's it. You don't have any queries? Is everything clear? Connect to me is something that, okay, I can give you my email address. Okay, let me just say, okay, email is something that I reply at the end. Okay, it takes me like, I will reply back to you in 2 days. WhatsApp or phone number is the worst thing. I never pay attention to my WhatsApp call because I'm always in a training. The thing is, if you want, you can connect to me on LinkedIn. Okay, I think. Atlassian is a company. What do you mean by Atlassian? Okay. So Atlassian is a company which is trying to implement tools which can be done for so Atlassian is a company which you should look at as well. So what it is doing is it trying to automate things for the DevOps part of you. So if you look at it, there's something known as Trello, and there's something known as Jira. See, the thing is, certifications are not necessary. The thing is, okay, I am here. Okay, before that, let me finish my things. So I've given you three things. I do not normally reply like at the same time. Like I do not reply immediately, because as you can see, I'm currently busy with you. Then I'll be training someone else. Then I'll be consulting someone else. So normally it takes me around 2 days max to reply to someone, but I'll just reply to you as well. Again, going back to the thing that when you talk about certifications, okay, I am an HR. I have come to your college to actually hire you. So, the question that I have, that is, I have 15 minutes with you. So the thing is, how much do I know about you in 15 minutes? I cannot learn everything about you in 15 minutes. So the thing is, 15 minutes give me a very less time to judge you. The thing is, now the recruiter wants to know a lot about you. So the thing is, one thing happens is at the screening phase. Okay, I'll just write it in VS Code. Okay, I'll just write it here. So the first thing what happens is that screening phase. Screening phase, your resume goes to a person. Now the thing is, when I look at a resume, the thing is, I want to shortlist people. Like I have received resume for 500 people, and out of this, I want to just conduct interviews for 100 people. So I'll shortlist on the basis of resume. So now the thing is, you might be amazingly good and everything, but can you tell this to the recruiter that I'm good on the basis of resume? That if I just have a resume of a person, I cannot see how good he really is, because right now, as I can see, I am talking to 112 people. It gives me really hard time to understand who is good and who is not. So now if I have a resume, yeah. So I have two things that I can have on the resume. The easiest thing to get is a certification. So if I'm applying for a Docker job, or if I'm talking about cloud computing, then a certification will tell me that this guy has invested some time, and this guy has invested some time, money, and because he has a certification, he is sure to know something about cloud. So if I have a cloud computing certification like AWS Solutions Architect, I at because I have cleared it, the recruiter knows that I should know a good deal about AWS. Because if I do not know a good deal about AWS, I would have never been able to crack this certification. So if I have resumes, if five people, or if like 500 or 500 people have written that they know about cloud computing, and if there's a guy who talks about he has like certification AWS Solutions Architect, so the thing is, this will give him a priority to get selected in the first round. Now another thing is that if they're coming to hire you for AWS cloud, this will value. If they are coming to hire you for Azure cloud, they will not talk about the AWS Solutions Architect. They'll prioritize on the Azure certifications. But the thing is, even if you have AWS certification, it will give you the secondary thing. So firstly, they will prioritize on Azure certifications. Then they will screen people who have AWS, and then out of, if they have some slots remaining, they'll choose people who do not have certifications. Okay. Another thing about certification is not in the screening phase. It is on the salary or compensation. This is not something that you will look in a lot of big companies. This is one thing that happens really badly in India. It happens from the HR. So the thing is, for example, a base. Okay, they came up with a job and they are saying they will pay like 7,50,000 rupees for a job. They will say that they will only pay this for certified people. If you're not certified, the compensation is 7 lakh rupees only. This is just an excuse. This is just an excuse that HR try to save money for the company, and you cannot do it at all. This only happens at the freshers level. So this is something that I have experienced as well. A lot of people, they will say that you do not have this certification, you do not have this, we want to hire you, but you are asking for a lot of money. So another thing that certification helps you at practical level, which should not happen. This is like a evil of society. So it helps you with compensation as well. Now, other thing is, when you have done certification, because of certification, you are actually sure to know something about that. So when you look at the certification courses, the courses are well structured. The thing is, currently what happens that when you're learning from a education point of view or in your BTech, BTech cannot be technology specific. So they're trying to help you learn that how do you actually work with cloud computing as a whole. When you look at courses, they are well structured. The thing is, if I want to learn about AWS, the thing is, if I go online, if I read a lot of blogs, I am not having a well structured learning. And the thing is that first thing is that when I said, like, when I talked about these technologies, the first thing that people think that how do I actually go on and learn about these technologies? So the thing is, if I didn't have this cloud train, if I didn't have this 12-factor app, actually I learned about them very late in my life. And if I do not have these things, how do I know what to learn? Because the thing is, this is one philosophy from a Chinese philosopher as well, that there are three things about any learning. Firstly, you do not know what you do not know. Then you know what you do not know, and then you know everything that you know. So at the first stage, when you do not know what you want to learn, the thing is, okay, someone said me like go and learn about cloud computing. The thing is, I do not know what to know in cloud computing. Like there's EC2, there's Lambda, there's a lot of other things as well. But how do I know that if these things are useful for me or not? So this is what happens in course things. So take up a technology. I think AWS associate level certifications are really good. When you take up the courses on that, you actually convert unknown into known unknowns. Again, with all your time right now, there will be a lot of things that will not give you a lot of sense. So the thing is, course will okay. So the courses will help you waste not waste time in learning things which are not useful. So they will be structured around a specific area, and you will know because AWS is a really big organization, and the TOC that they have or the course content that they have is very well defined and is something that the industry needs. So the courses, even if you do not have a certification, try to do courses. So the thing is, when I go here, I have containerization. I see that I need to learn about containerization. I know that there's a Docker is required for containerization. So I'll take up a Udemy or any other course for or any other. I will try to find if the Docker has an official certification. If you have that official certification, just take up the course. Do not waste money in the certification, but just take up the course because that course will give you the maximum amount of information in which you can use Docker with. So that is one thing. So this is some importance of certification. Other thing that you should have is a portfolio. Okay, so my recruiter, if I have a really good recruiter, he wants to see if I actually know something. So the first way to know and the easiest way to know if someone knows is from a certification. This thing is not easy from your point of view, but this has a higher success rate than certifications. So you start writing about things. You start creating projects and you start uploading them to GitHub. Or maybe you write a research paper, or maybe you start writing a technical blog. So one thing that students do, that when they are trying to learn these things, whatever they have learned, they actually write that on a blog. Okay, so tell me one thing. Okay, we don't have our time to actually ask you for that. So when I am saying that if I'm writing a technical blog about my own learnings, okay, so if I'm saying that I took up a technology, I started learning on it, this is what I have learned, this is what I have learned now, this is what I'm going to do in future as well. So does this tell me how good you are at learning and how you are at sharing? So when I'm writing a technical blog and I'm writing some analysis of something else as well, so there are three things in anything, which is learn, do, and share. So this is something which you do normally when you're working. So if I'm writing a technical blog in which I'm writing about my learning experience, right? Does this blog tell someone that how good am I at learning, right? So does my blog tell everyone that how good am I at learning? Certifications just tell them that how good am I learning because I took up a course, I gave an exam, and I showed them that I am able to learn. But when I look at a technical blog, do I have a timestamp feature thing? Yeah, totally up to you. You don't have to go with that deep, but try to talk about how you are learning things. Read a, what you do is you, okay, blog doesn't have a structure. The thing is you start writing. Do not think about that because I face this issue as well. The thing about blog is you just start writing. You do not think about what should I write, and at the beginning what should I write or what should I take into consideration as well. But when you start writing, first gain the habit of writing a blog. After you have gained a high habit of writing a blog, see what other people are writing in your blog. Then what are they writing? Try to include that in your blog as well. And with As you go forward, you will see that you are learning things what you should put it in, but that's not the case. The thing is, you have to display how good you are at learning. And as I said before, that the primary thing that they come up and to see if you're learning is your ability to learn. Blogs are the best way to show someone that what is your ability to learn, because it's a time-stamped environment. You actually tell people or your recruiters that at this point of time I learned this and it took me this much time to go through this thing, and it's like a diary. It gives them a better approach that you can learn, you can learn, you can do, and you can share as well. Okay, that's good as well. That's good as well. So this is something which is the most important thing for your screening phase. Then comes your portfolio. Then comes your certifications. But the thing is, okay, it's not like I have a really bad blog and it goes above AWS Solutions Architect certifications. Your blog should be good as well. But if you keep on writing blog, it will eventually become good. Your research paper should be good as well. Your projects should be somewhat good. But the thing is, if you look at the same quality of things, your blog comes at the top, the projects come at second, and the thing, your certifications come at the last thing. And if you do not have a thing, you are the least prioritized person. Is this clear? Does this help you with certification and resume thing as well? Was this information? Do you have any doubts in this? Okay, anyone with doubts? So far, we still have 10 minutes. Any other questions that you want me to ask about anything? You can ask me about your course as well. You can ask me about, if you have any questions, like specific questions, like should I pursue further studies or should I go in like look for a job? Where do I look for a job? Well, actually, I cannot help you. Where do I look for a job as well? Yeah, okay. One important thing that I completely forgot. That is something that I do not want to talk about that because I do not have enough information on that. That is something people are talking about, but this is not something related to my field, so I'm not a good person to talk about that. But before that, if you go to this website, so IBM has acquired Red Hat, and I told you that there are a lot of good course structures that you can follow. So this is one of the best places, but this is really good for like people like what do you say? People, it's more Java oriented. Even IBM is more Java oriented because like when you look at people who are working at IBM, they are mostly working with Java. So Red Hat was acquired by IBM, so this is indirectly another IBM offering that you have. So they have free books, they have free cheat sheets, they have really good books to be honest, and they have really good microservices. Sorry, video series. So for example, when you look at DevOps, there's a free book on that. There are a lot of videos in that. So this can be a like go-to place to learn about things. Again, there are a lot of information on that because whatever I have given you is I've bombarded with you like with hundreds of things so far. The thing is, I want you to cover all these things over a period of 2 or 3 years, or maybe like 5 or 6 years. So this is your goal for 5 or 6 years that I have mentioned so far from a development point of view. So best thing of this thing is developing microservices on Kubernetes. And there's one more book here. I think it's here, Learning Guide. So this was one of my best experience that I had about microservices, where someone told me how do you write microservices and how do you think about that. So I'll just copy and paste this as well. Before doing this, just learn Docker, just learn some parts of Kubernetes, just learn Jenkins and some part of Git, and then you are ready to go for this thing. So this is the first thing that I would like you to start with microservices as well. I think the part which I want to know is of 1 hour or something. Uh, I think this is the thing that you have to look at. So you can go from the same sequence that they have as well, but this is the point which you look into. As a person, this will help you a lot because the thing is, when you're talking to recruiters and if you have been working through these things, the way you actually, okay, this is not what I wanted to show. Okay, can one of you, okay, do you have a CR? Like, do you have a class representative or something? Someone? Okay. I found it. Okay, so this is part of the same thing. This is something that I would like you to learn after Docker or Kubernetes or something. No, not after Kubernetes. Look at this after you have learned Docker, Jenkins, Git, and AWS. After that, this is on the basis of Java or Spring Boot. This will give you a brief not a brief, but a high-level overview of how do you write applications for cloud environment. So this is something I will highly recommend. And again, this is something, all the things that I've talked to you about, this complete landscape, think about that you will take like 6 or 7 years to actually perfect this. Okay. I have given you a lot of resources where you can do that. The thing is, the one but after that, choose up one random thing at a time on the basis of this thing and learn about it. Resources, you go to developers.redhat.com, they have a lot of resources for all the things that can make you have a like proper well-structured code for these things. So is that kind of okay? Is it clear now? The thing is, I can go on and talk about like for 1 and a half hour more, but I would like to shut it down here. So the thing is, everything. I hope everything is clear. Do you have any questions? Okay, when I asked, okay, no questions. All right. So the thing is, was this training helpful? Sorry, no, not this training. Was this session really helpful for you? Oh, no, sir, by Gaurvendra Singh. Okay, very much. All right. Are you happy with the session? Did you learn something more? Did it clear your doubts like which you had? Okay, so can we wrap up? All right, that's cool as well. It was good talking to you people. I forgot the name of the coordinator we had. I think Achal was. Okay, I'm really sorry. I forgot your name. I suppose that there was a coordinator here in this chat. Avita. Yeah. Hey, Avita. So can we finish this session now?
Yes, sir. I would like to personally thank you. And judging from the comments and interaction which was coming out of the students, I feel that this session was very successful and they would be taking the benefit out of it. Thank you once again. Yes, we would wrap it up.
You're welcome. You're welcome.
Uh,
Uh, Avita, can you hear me?
sir? Yeah, yeah. Hello.
Okay, I know that you are saying thank you, but you can stop here because I want to see her messages. So the coordinator here, can I like, do you have any last words for me, or do you want me to like end the session now?
This would be fine, sir. We would like to end the session now.
Okay, I think you guys are following me on my Twitter handle. So just go to this thing. I actually find a really good resource, which was like because of the Corona situation that we are in, a lot of companies they are giving their paid courses for free. So I will tweet the okay. I'll just try to find that resource again, and I'll tweet the location on my Twitter account. So if you follow that, you will be able to see that resource. So I think Avita is not replying right now. So I'll just end this session. It was pleasure. It was a really big pleasure talking to you guys, and I wish you all the success in your life. So I'm just finishing this training session. It was really good to know you. So over and out. See you guys. Have a good day. Bye.